Part 4. You will hear a lecture about the growing problem of space debris and potential engineering solutions. First, you have some time to look at questions 31 to 40. Now listen carefully and answer questions 31 to 40.
Good morning. Today we are looking at one of the most critical environmental challenges of the 21st century. But unlike climate change or ocean plastic, this pollution is invisible to us on the ground. I am talking about space debris, often called space junk. When we look up, we see a clear sky. But if we had radar vision, we would see a swarm. The European Space Agency estimates there are over 128 million pieces of debris in orbit. The vast majority of these are tiny, smaller than a tennis ball, which makes them impossible to track from the ground. You might think a fleck of metal is harmless. However, in space, physics changes the rules. These objects are traveling at 28,000 kilometers per hour. At that immense speed, even a screw hits with the force of a hand grenade. So where does it all come from? People assume it's mostly dead satellites, but the reality is messier. A major source is actually fragmentation events. This happens when the upper stages of old rockets, which have been floating there for decades, suddenly explode. This is usually caused by residual fuel that was left in the tanks and has become unstable over time. Another surprising source is wear and tear. The environment in space is harsh. The intense ultraviolet radiation from the sun degrades the thermal blankets on spacecraft, causing them to peel. This releases millions of tiny flakes of paint into orbit, creating a sort of abrasive dust cloud that damages sensors and windows. The nightmare scenario, however, is collision. If two large satellites smash into each other, they don't just stop, they shatter into thousands of new pieces. These pieces then hit other satellites, creating even more debris. This theoretical chain reaction is known as the Kessler syndrome, named after the NASA scientist who predicted it in 1978. If this happens, Earth could be surrounded by a shell of shrapnel that makes leaving the planet impossible. Who is most at risk? Obviously, uncrewed satellites are vulnerable, but the highest stakes are for astronauts. If a piece of junk punctures the International Space Station during a spacewalk, the result would be fatal depressurization. So, how do we clean up the mess? The traditional method is avoidance. Operators try to move old satellites into a so-called graveyard orbit, far above the useful zone. The problem is that this maneuver requires the satellite to save a significant amount of propellant for the end of its life. This adds weight and cost, so historically, companies haven't done it. Now, engineers are testing active debris removal, basically garbage trucks for space. One European mission, called Clear Space 1, plans to use a giant set of mechanical arms. However, capturing a tumbling object is hard. A simpler method being tested involves firing large nets to entangle the target. It's primitive but effective. Another, more futuristic proposal involves using ground-based lasers. These wouldn't burn up the debris, rather they would gently nudge it. By heating one side of the object, you create a tiny amount of thrust that slows it down, causing it to fall back to Earth and burn up in the atmosphere. However, the biggest hurdle isn't technology, it's law. According to the Outer Space Treaty of 1967, a satellite belongs to the launching state forever. This creates a problem of ownership. Even if a satellite is dead and dangerous, the U.S. cannot legally remove a Russian satellite without permission, and vice versa. Until we fix these diplomatic rules, the junk will keep piling up.
That is the end of part 4. You now have 1 minute to check your answers.